Acid and bases. In this chapter, acid and bases is break into 4 different parts. First, about the acids itself, bases and alkalis, the pH scale, and type of oxides. Now take note that color coding is used to enhance your learning experience. Highlighted in red are the definitions you must memorize by heart. The green colors are the important facts that you have to remember. And the blue represent the formula or general equations that you have to remember, because without them you could not write the rest of the formulas. In this first section of acids, the first learning objective is to define acids as substances that produce hydrogen ions in aqueous solution. The second learning objective is to describe the properties of acids and their reactions with metal, bases, and carbonates. Now, what is an acid? Examples of commonly seen acids are like tartaric acid in the grapes, citric acid in oranges, and lactic acid in yogurt. The commonly seen acid in the lab as a bench reagents are like hydrochloric acid, nitric acid, and sulfuric acid. Now, you will notice the learning objective is displayed clearly on the upper right hand corner. So as you learn the content, please take note of what is the learning objective within this slide. So this slide asks you what is an acid. Now let's look carefully at the explanation. Highlighted in red means it's a definition. An acid is a substance that produces hydrogen ions, H+, when dissolved in water. Dissolved in water also meant aqueous solution. So take note that you need to write hydrogen ions rather than just spelling it H+. Hydrogen ions are responsible for the properties of an acid. Without hydrogen ions in a solution, then the solution will not have acidic properties. There's some example acid here. For example, hydrochloric acid HCl, when it's in aqueous form, you will find hydrogen H+ ions and chloride ions in the solution. Nitric acid, H+ ion and NO3 ions. Sulfuric acid will form H+ ions as well as sulfate ions. And even vinegar or ethanoic acid, you have H+ ions and ethanoate. Now take note, it is these hydrogen ions in the solution that give rise to acidic properties. Now let's try this quiz. Give yourself a short little moment to try it out and click pause while you're trying these questions. Okay, welcome back. Now, name the ion responsible for the properties of an acid and give its chemical formula. The name is asking you about the name of the ion, so you must write hydrogen ion, spell it correctly, and give its formula H+. Now, give the chemical formula of the following acids: sulfuric acid H2SO4, nitric acid HNO3, hydrochloric acid HCl, and ethanoic acid CH3COH. You need to remember this formula of acids which are commonly used. And then last but not least, the most important thing, which is the first learning objective, is define an acid. So please memorize by heart. An acid is a substance that produces hydrogen ions, H+, when dissolved in water or in aqueous solution. Now, is hydrogen chloride gas, HCl gas, the symbol G means gas, an acid? Now this hydrogen chloride gas, as you can see, they exist as molecular form HCl molecules. So they exist as covalent molecules. It is not dissolved in water, so it cannot produce H+ ions. Therefore, this is HCl gas, but it is not an acid when it's gaseous. So let's look at the property of acid in detail. How does acid get its property? A substance has acidic properties only when it is dissolved in water. And when it's dissolved in water, it has to ionize to produce H+ or hydrogen ions. Then it is called an acid. A clearer example here, as you can see, this is HCl, covalent molecules in organic solvent. In organic solvent, HCl is dissolved but does not ionize. It still exists as covalent molecules, hence it is not an acid. And even if you put a piece of carbonate or metals inside there will be no observation. Now, when HCl dissolves in water, it ionizes to give hydrogen H+ ions and chloride ion. It is this H plus ion that gives rise to the acidic property of the acid. Hence, hydrochloric acid is produced. Next, learning objective 2, we want to look at the properties of acid. Some general properties like sour taste, blue limers will turn red, and as well as when acid is dissolved in water, it forms solution with ions, hence it can conduct electricity. Next, we look at the reactions of acid with reactive metals. Now this is the reactivity series of metals that you should have memorized. The red color represents the reactive metals from potassium, sodium, calcium, magnesium, aluminium, and then those are very reactive metals. And zinc, iron, lead are the reactive metals but not as reactive as the top 5 metals. Hydrogen down here is not a metal, okay, but it's placed in this order to let you know that anything below hydrogen, you will not react with acid. For example, copper, silver, and gold. These 3 metals will not react with acid. So acid reacts reactive metals to form salt and hydrogen gas. It refers to from potassium all the way to lead. They can react with acid to form a salt and hydrogen gas. Let's highlight in green. So, the general formula is metal plus acid gives you salt and hydrogen, and take note that this metal refers to only reactive metals. Now, hydrogen gas is produced. How do you test for gas? You put a lighted splint, a lighted wooden splint at the mouth of the test tube. If there's hydrogen gas coming out from this test tube, the flame will extinguish with a pop sound. So you have to remember the test for hydrogen gas. So what is a salt? A salt is produced when hydrogen ions in acid is replaced by a metallic ion, for example N+, K+, these are metallic ions, or ammonium ion. So, definition of a salt, you have to remember, a salt is a substance formed when hydrogen ions in the acid is replaced by a metallic ion or an ammonium ion. Let's look into a greater detail. This definition again, please remember properly. A salt is a substance formed when hydrogen ions in the acid is replaced by a metallic ion or ammonium ion. For example, this is sulfuric acid. When magnesium replaces the H+, the hydrogen ions in the sulfuric acid, it forms magnesium sulfate. Hydrogen is being replaced by magnesium, and this magnesium sulfate is known as a salt. Now, copper 2 oxide reacts with hydrochloric acid. Now, in acid, there's always a hydrogen ion. So, when copper replaces hydrogen ion to form copper 2 chloride, the copper 2 chloride is a salt. So, the definition of a salt is a substance produced when hydrogen is being replaced by a metal or ammonium ion. So, now we look into the properties, some reaction of acids and metals. Magnesium and sulfuric acid form magnesium sulfate and hydrogen. Take note of magnesium replacing hydrogen to form magnesium sulfate and hydrogen gas. So whenever a metal reacts acid, there's always a gas produced. It is observed as bubblings, or you call it effervescence. Hydrogen gas is produced. A zinc metal reacts hydrochloric acid, it forms zinc chloride and hydrogen gas again. Now, how about lead? Not all metals react acid to give a salt and hydrogen gas. Lead appears to be unreactive with hydrochloric acid and sulfuric acid. Why is it so? First of all, of course, when lead is very low in the reactivity series compared to the rest of metals, its reaction with acid will be much slower. However, the reaction will not proceed for long. For example, when this acid reacts with the lead, okay, the lead will form a layer of insoluble chloride or sulfate. If you have sulfuric acid, you form lead 2 sulfate because the lead will replace hydrogen in the sulfuric acid. If you have hydrochloric acid, the lead will replace hydrogen in the HCl to give you PbCl2. And it is this insoluble layer of salt that is produced, preventing further reaction between the acid and the lead because the acid cannot reach the lead metal anymore. So when acid is outside, the metal is inside, and this layer of salt being unreactive will prevent the acid from reacting with the metal. Hence, reaction will stop. So take note, the fact is lead 2 chloride and lead 2 sulfate are insoluble in water. In the chapter of salt preparation, you'll learn more about the soluble insoluble salt. But meanwhile, just remember the lead 2 chloride and lead 2 sulfate are insoluble in water. Next, acid react with all carbonates and hydrogen carbonates to form a salt, water, and carbon dioxide. This is another general equation you need to remember by heart. Any carbonate plus acid will form salt, water, and a carbon dioxide gas. So how do you test for carbon dioxide gas? You bubble the gas into a test tube of lime water. And lime water is also calcium hydroxide. Please remember that. You produce a white precipitate, which is a calcium carbonate. So a test for carbon dioxide gas is to bubble the gas into a test tube of lime water. When a white precipitate is produced, it means that the gas is carbon dioxide. Some example of reaction of acid and carbonate. Sodium carbonate and hydrochloric acid form sodium chloride. How do you know sodium chloride? Because in HCl, the H is replaced by a metal. In this carbonate, the only metal you have down here is sodium. So therefore, sodium replaces hydrogen to form sodium chloride. Salt is produced when the H plus is replaced by a metal. So sodium chloride is a salt. And then water and carbon dioxide, you have to remember by heart that these are also produced. Another example, zinc carbonate and sulfuric acid. Now, the salt is produced when hydrogen ions in a sulfuric acid is replaced by the metal from a carbonate, which is zinc. So from zinc sulfate as a salt. And at the same time, it produces water and carbon dioxide. Now let's pause for a moment and try these questions. State 3 physical property of acid. Please try yourself, pause it for a moment. Right, welcome back. The 3 physical properties of acid is it has a sour taste. Physical property refers to properties that are not due to the reactions, not chemical reactions. For example, sour taste, turn blue, litmus paper red, and when dissolved in water to form solution, it can conduct electricity. It is a good conductor, which is a property of all acids. Now, acids only react with reactive metals to produce a salt and hydrogen. Acids react with all carbonates to produce a salt, water, and carbon dioxide gas. All these are important facts you have to remember. Next, the third reaction is about the bases. Acids react with metal oxides and hydroxides to form salt and water. So what is metal oxide and hydroxide? They are known as bases. So we can define bases as metal oxides or hydroxides. Some example of bases, like for example, if you talk about metal oxides, will be calcium oxide, magnesium oxide, zinc oxide, copper dioxide, all the metallic oxides, they are called bases. And hydroxides are also called bases. So a base plus acid, a general equation will be a base plus acid gives you a salt and water. And this is very important. Please highlight in blue. This is a general formula, general equation, and you must remember by heart. So what's the name given to this reaction? Why is it so important? This reaction is also known as neutralization. Okay, when a base reacts acid, it neutralizes the acid. So, definition of neutralization. Neutralization is defined as a reaction between an acid and a base to produce a salt and water only. Is there any gas produced? No, only salt and water. In the previous two examples of reaction of metals and carbonates, you realize metals react acid to produce hydrogen gas. Carbonate react with acid to form carbon dioxide. But bases, you only form salt and water only. Remember the definition. So, zinc oxide, a metal oxide is a base. A base plus acid gives you salt and water. Again, a salt is produced when a hydrogen ion is replaced by the metal ion from the oxide, which is zinc. So zinc sulfate is produced as a salt. Note that no gas is produced. Next example, copper 2 oxide nitric acid. The hydrogen ions is replaced by the copper to form copper 2 nitrate and water. So this is a salt and this is water. Again, note that there is no gas produced. Okay, sodium hydroxide and hydrochloric acid, likewise, hydrogen ions is replaced by a sodium to form sodium chloride as a salt and water. No gas is produced again. Okay, this is an example. Calcium hydroxide is a base. A metal hydroxide is a base. Rare acid to form a salt and water. How do you know this is a salt? This is produced from an acid when a hydrogen ion has been replaced by a calcium, which is a metal ion. So this is called a salt. Now let's look at the role of water in acidity. As we saw in the previous example, when HCl dissolves in organic solvent, for example oil or methylated spirit, it exists as covalent molecules of hydrogen chloride. So no hydrogen ions are present. Hence, a metal will not react with the HCl gas in this solvent. When HCl gas dissolves in water, it forms HCl aqueous. And you know HCl aqueous means hydrogen ions and chloride ions are present. So the hydrogen ions can now cause the solution to become as acid and react with magnesium ribbon to produce hydrogen gas. So observation is effervescence or bubbles of gas produced. Now let's pause for a moment and try these questions to see whether you understand the lesson learning objective 2. Welcome back. Metal oxides and metal hydroxides are called bases. These are the definition of bases you must know. And a soluble base is called alkalis. You'll learn more about alkalis in the next section. Acid react with all bases to form a salt and water only. This is very important, and the name for this reaction is neutralization. And define neutralization. Neutralization is defined as the reaction between an acid and a base to produce a salt and water only. Take note, no gas is produced. What must be present before an acid can show acidic properties? And this is a very important thing you must know. It is the hydrogen ions that's responsible for an acid to have the acidic properties. Okay, this is a partial question you may want to try. Lime juice is added to some sodium carbonate powder. A gas is given off. Name the gas. A little hint to you, this is a carbonate. So what do you think is the gas produced? And how do you test for the gas? Pause for a moment and complete the blanks. Alright, welcome back. Sodium carbonate, it is a carbonate. Carbonate react with lime juice, which is an acid. It produces carbon dioxide gas. It's very important for you to know how to test for hydrogen gas and carbon dioxide gas. Here, to test for carbon dioxide gas is to bubble the gas into a test tube of lime water. Lime water is also calcium hydroxide. Now, observation is white precipitate is formed in lime water, and this precipitate is fine, very fine white particles, solid particles that's produced in the lime water. And uses of other acids. Common use of acids, for example hydrochloric acid, is to remove impurities such as rust or scale from metals and aluminum alloys. Phosphoric acid is added to food and beverages to give them a sour taste. And ethanol acid, which is vinegar, is used as a food preservative and flavor enhancer. And some people like to add this vinegar into noodles to eat. It's a little bit sour, but it tastes better than a plain noodle.